Welcome to this lesson on elastic potential energy, also known as spring energy. This is a fundamental concept in physics that explains how energy can be stored in objects when they are stretched or compressed. Elastic potential energy is the energy stored in an object when it is stretched or compressed. The key characteristic of this energy is that the object can return to its original shape and release the stored energy when you let go. Think of it like a rubber band that snaps back when you release it. You encounter elastic potential energy in everyday life. When you pull back a bow and arrow, the bow stores elastic potential energy. Springs in mattresses, pens, and toys store this energy when compressed. Even a trampoline stores elastic potential energy when you jump on it and it stretches downward. Springs are perfect examples of elastic potential energy in action. When you compress a spring by pushing it together or stretch it by pulling it apart, the spring stores elastic potential energy. This stored energy is ready to be released when you let go of the spring. The formula for calculating elastic potential energy is EPE equals 1/2 kx squared. Here, EPE represents elastic potential energy measured in joules. K is the spring constant measured in newtons per meter, which tells us how stiff the spring is. X is the displacement in meters, which is how much the spring is stretched or compressed from its normal position. The spring constant, represented by K, measures how stiff or flexible a spring is. A higher spring constant means a stiffer spring that requires more force to compress or stretch. A lower spring constant means a softer, more flexible spring that requires less force. For example, a car suspension spring has a high K value, while a slinky toy has a low K value. Let's work through an example problem. A spring with a spring constant of 200 newtons per meter is compressed by 0.5 meters. How much elastic potential energy is stored? We are given K equals 200 newtons per meter, and X equals 0.5 meters. To solve this, we apply the formula, EPE equals 1/2 kx squared. Substituting our values, EPE equals 1/2 times 200 times 0.5 squared. This becomes 1/2 times 200 times 0.25, which simplifies to 100 times 0.25. The final answer is 25 joules. This means the compressed spring stores 25 joules of elastic potential energy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.